3.2 Measures of variation. The data show travelers spending in billions of dollars for a recent year for sample states. Find range, variance, and standard deviation for the data. Okay, let's start out with the range. Range is the largest number minus the smallest number. So it looks like the largest number is 110.8 billion minus the smallest number looks like it's 20.1. So that would give us 90.7 billion as the uh, range of this data set. Next, we're going to find the variance. To find the variance, we need to know what the mean is. Now, it's important that we pay attention to the words in the problem, sample of states. So what I'm going to be finding is the sample mean. And sample mean is the sum of all the numbers divided by however many numbers. Let's go straight to the calculator and find the mean. Second, stat, over to math. Number 3 would give us the mean. Since this is not a problem on mean itself, we can go straight to the calculator and pick up the mean as 45.74. If this question is testing you on the concept of mean, then you would show me the sum of L1, the sum of all these numbers, and then divide that by the total number. Let's see, how many do we have here? 2, 4, 6, 8, 10 divided by 10. Okay. Alright. Standard deviation is the square root of the variance, and we're going to have to get to variance first. Standard deviation measures how far numbers are away from the mean, typically, in your data set. So we're going to take each number minus the sample mean. And then we're going to square those deviations. So variance, the formula is S squared. S is the standard deviation, sample standard deviation. S squared is the sample variance. Is the sum of all the x minus x bar squared and then divided by n minus 1. Before I start the video, I entered all 10 numbers in my list 1. So now I'm going to define list 2. In list 2, I want each number in L1, which is my x. So I'm going to define list 2 as L1 minus the mean, which is 45.74. And then I'm going to square all the deviations. So 20.1 minus 45.74 will be the deviation, and then the square deviation will be that number squared. So these are the square deviations: 657.41, 149.82, 577.92. In the interest of time, I'm going to stop writing them, but these are going to be part of your work. So make sure you do write down these numbers in your on your paper. So I want the sum of L2. So let's get back onto the main screen. Go over to second step, over to math. Number 5. Sum of list 2. Sum of all the square deviations. That gives us A026.964. And then there are 10 numbers, so I'm going to end up dividing by 9. And after I divide by 9, that number is my variance. 891. I'll round it to 9, but to compute standard deviation, I'm going to use this number. It carries more decimals that will make my standard deviation more accurate. Okay? So as I said, standard deviation is the square root of the variance. That means I'm taking the square root of this right here, sum of x minus x bar squared over n minus 1. So that'll give me the square root of 891.9 approximately. So I'm going to take the square root of this number, second x squared, which takes you to the square root, and I want the square root of the answer. So that gives us 29.9 approximately. That's the standard deviation. And again, the meaning of standard deviation is how far a typical number in your data set is away from your mean, in this case, sample mean.